Alright, so this section is titled 8.6 Counting Principles, but what this really starts to get into is the beginnings of probability. And when you're talking about probability, it's really important to figure out how many total outcomes there are. That's really the first step in calculating probability. So this is really like part one of probability. 8.7 is going to be kind of the final piece to that. So the basics here, we're really laying the foundation for the next few days. Alright, so a lot of word problems in this section. The numbers 1 through 8 are written on a paper and placed in a box. You select a number, write it down, put it back in the box, and select a second number. How many different ways can the two numbers be drawn, add up to 12? So, what we're looking at is to do this in probability, it is very important to know how many possible ways can I write this down. How many possible outcomes are there? There are 8 numbers, and I'm going to select that out of this 8 twice. So I want to know how many different possible ways I can come up with this combination. So it's possible, so what I like to do is, let's start with the smallest number. It's possible to draw 1. And if I draw a 1, I could, the smallest outcome I could go is 1, 1. I could draw a 1, then a 2, a 1, then a 3, a 1, then a 4, a 1, then a 5, a 1, a 6, a 1, and a 7, a 1, and an 8. Now I wouldn't write 1 and 9 because there is not a 9 on a piece of paper. So I would stop there. Now, notice I can draw, this one right here is actually important to talk about. It is possible to get a 1 and then a 1 because it specifically says in the directions that you draw a number and replace it back in. Now, it's also possible to draw a 2 as a first number. And I could follow that up with a 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. And obviously, I would not go any further than 8 because, again, I can't draw a number higher than 8. So this may sound like an exercise in tediousness, but we are going to write down all the possible outcomes. So 3, 6, 3, 7, I'm hoping you see the pattern on your own and that you're capable, for at least this one time, writing out all of the possible answers. 4, 5, 4, 6, 4, 7, 4, 8. Next column, 5, 1. It's possible to draw all my 5s. If I draw a 5 as the first number, what are the possible outcomes that I could get after that? If I draw 6 as the first number, what are the possible outcomes I could get after that? 6, 6, 6, 7, 6, 8. If I draw 7 as the first number, 7, 6, 7, 7, 7, 8. And then last but not least, 8, 1, 8, 2, 8, 3, 8, 4, 8, 5, 8, 6, 8, 7, 8, 8. All right, so first, what this means is there are really 64 possible ways. So there are 64 possible ways. 64 ways. 64 ways to draw two numbers. Now, I do not expect you to write all of those 8 on the test. I do it to show you there's an easier way to calculate the number of ways to draw these 8 numbers. If you notice, you're selecting, you had 8 numbers to choose from at the beginning. All right, you replaced that piece of paper. There were still 8 pieces of paper to choose from the second time. And if you had multiplied those, you could have actually done a really quick multiplication and not had to write down nor count up. So yes, I would prefer you to be doing this than maybe writing all of these out. But now the second question is, how many different ways can two numbers be drawn up to 12? So first, it is good to notice that the 64 comes from 8 times 8. But now that I've got this big list, I can actually figure out, well, which ones of these combinations add up to 12. And before I do that, I'm going to actually copy this for a second. I'm going to use that in a few minutes. But before I go any further, which ones of these combinations add up to 12? And I'm going to start circling. It looks like this adds up to 12. This adds up to 12. 6 and 6, that adds up to 12. 7 and 5 add up to 12. 8 and 4 add up to 12. So there are 5 different ways to add to 12. 5 ways to add to 12. If you notice, none of the other combinations add up to 12. So now we're not talking about probability yet, but that would be 5 out of 64 possible outcomes. Now, here is a very similar question. The numbers 1 through 8 are written on a piece of paper and placed in a box. You select two numbers at the same time. How many different ways can the two numbers be drawn add up to 12? This looks like a very similar question, but what we did on the last, this is actually not correct in terms of there are not 64 ways to calculate these pieces of paper, because I'm picking two pieces of paper at the same time. So I cannot pick a 1 and a 1 because all of these are not even options because I can't pick the same number at the same time. So if you notice, and if you were to actually count these up, there are 56 of them. Now, how do I use the numbers in this problem to get a total outcomes here to come up with 56? Well, I did have 8. I still had 8 pieces of paper in the first pick. Now, in the second pick, there was really 1 piece of paper already out, so I only had 7 left to choose from. So what I really multiply here is 8 times 7 to get 56 total outcomes. Again, I'm hoping that you don't need to write down all of these outcomes. And then maybe in your head you can think of, well, what are the numbers that can add up to 12? There's 1, 2. Now I can't count this one because it's a double. 3. So here in this situation, there are 4 ways to get a 12. Right, so essentially what this leads up to is our fundamental principle of counting. And this is probably the basics of probability. In the last problem, you had 8 pieces of paper. That's X possible outcomes. There was a second event. Whether it was replaced or whether it wasn't replaced meant there was a second event that had either 8 or 7, depending on which problem you're talking about. Then the total number of outcomes is X times Y, possible ways for the 2 events to occur. So again, if you have 2 possible outcomes, the first event has X, the second event has Y, then it is X times Y, possible ways to occur. If you are going to flip a coin, which has 2 outcomes, and roll a dice, which has 6 outcomes, well, then there are 12 total different outcomes. I'm sure you could list them on your own. But here's actually a good question. How many different pairs of letters are there in the English alphabet? Assume you can repeat letters. Well, I hope your English teacher teaches you have 26 letters in the English alphabet. So if you're drawing pairs, that means you're going to have 2. Assuming you can repeat letters, I would not expect you to write down all of the outcomes here. I just expect you to do 26 times 26. Maybe type that into a calculator if you need to. That would total 676. All right, so here's building on the same concepts. How many different phone numbers are possible in the 203 area code, assuming the first digit in a 7-digit phone number cannot be 1 or 0. So you're going to have 7 different numbers to choose from. There are 7 different events happening. And in the first event, they say it cannot be 1 or 0. Right? That means there are 8 possible numbers that you could put here. 8 digits. Not 1, not 0, but there are still 8 left. The rest of the outcomes, you have 10 possible numbers to put here in every single one of them. All right, so you would do 8 times 10 times 10 times 10 times 10 times 10, so that's 1,000, 10,000, 100,000, a million. It looks like 8 million total different area or possible phone numbers that begin with 203. Okay, so in the next few slides, you're going to hear me refer to the word permutations. And a permutation is a fancy way for how many different ways can you order elements. So finishing a race is one way that to put in order. Electing a president, a vice president, a secretary, and a treasurer, those are a very specific order. Here, sometimes even like this first question, how many permutations are possible with the letters A, B, C, D, E, F? That's saying how many different ways can you order the letters A, B, C, D, E, F. So you could think of that if you had 6 friends and you wanted to put them in a line, how many different ways could you line them up? You're putting them in order. All right? If you had 6 books on a bookshelf, How many different ways could you order them? 6 different books. How many different ways could you order them on a bookshelf? I would not want us to list all of these out because this is essentially an application of our last theorem. You have 6, say you have 6 letters. You are going to put them in 6 different locations, all right? As you place the first letter here, you could choose from any one of those 6. So there are 6 possibilities, all right? But you had to pick one of them, all right? So no matter which one you picked, I'll cross one of them out. It didn't matter which one I crossed out. When you go to place the second one, there are only 5 possibilities left. So you've placed a second letter. So I'll cross out a second letter. Again, didn't matter which one I crossed out. After you've placed 2 letters, there are only 4 possibilities to place out. So I cross one more out, and then it's going to get repetitive from here. There are 3 possible letters from here. I'll cross out a third one. There are 2 possible letters. I'll cross one out. And by the time you get to the end, you're not going to have an option here. You're actually only going to have 1 letter in place. It's going to be after you've made the first 5 choices, you will only have 1 possible choice left. So by our fundamental principle of counting, we multiply these 6 events, and that's 6 factorial. So 624 times 5 times 6 is going to be 720 different ways. That is the same as 6 factorial. So you're going to get to know your factorials a little better in this section than you may have before. And if you notice this second question, how many different ways can 6 runners finish a race? Call those 6. So you have 6 runners. Call those different runners. Give them a name. Oh, sorry. This is exactly the same problem. Give those 6 numbers names, A, B, C, D, E, and F, and it is the same exact work. It is 6 times 5 times 4 times 3 times 2 times 1. It's the same as 6 factorial, and the answer to this problem is also 720. So, permutations. Again, permutations are when you're asked to order n elements. Put them in order. All right? You are asked to put in order, because order is extremely important when you talk about probability. If there are n elements, then n factorial is the number of ways they can be ordered. So if you had 3 appetizers to choose from, actually let's change that. Let's imagine that you had 18 people in your class. I'm getting ahead of myself. I'm thinking of a problem that we'll do down the road. So I'm not going to go any further. Forget I said anything. We'll get to the harder ones in a little bit. But so here's if there are 8 horses in a race, how many ways can the horses finish first, second, and third? So notice the change here. All right. They're only concerned with 3 events. They are only concerned with first, second, and third. The rest of the race doesn't matter. They want to worry about who can finish first, second, and third. So there's 8 horses running this race. All right. So picture your 8 horses: A, B, C, D, E, F, G, and H. 8 horses running a race. Any one of them could win. There are 8 possible winners. All right. But once a winner is chosen, boom, I've chosen one. I picked one at random. All right. So there are now only 7 horses left to finish this race, to finish second. All right. And after a horse has finished second, well, 2 horses have finished first and second. All right. And now there are only 6 horses left to choose a winner for third. So when you are putting pieces in order, again, this looks a lot like factorial, but it's really 8 times 7 times 6. And the way we write this mathematically is 8 factorial divided by 5 factorial, because if you notice, 5 factorial would cancel out the 5 factorial above it, and you'd be left with just this multiplication, 8 times 7 times 6, which would be 336 different ways to finish. All right, we will pick up in the following video.